I going back quickly, okay? So basically, we already talking about low pass filter, okay, and a high pass filter in general. And today I go into a detail with the level, okay? And they already given to you a circuitry for RL low pass and RC low pass. That means every time you see this circuitry, you know this is a low pass filter. And either they can be RL or RC, okay? And this is, if they can asking you, what is it? And the answer will be, this is the output of the low pass filter, no matter RL or RC low pass filter, okay? The dividing line between the passing of low frequency and rejecting high frequency is the cutoff frequency or minus 3 dB. That means at this point right here, okay, going down, you can see FC. FC means cutoff frequency. Also be critical frequency or corner frequency or break frequency. Okay? They get too many different names. So what is the cutoff frequency? Okay? The cutoff frequency, they're telling you at this frequency, the output going down 3 dB, minus 3 dB. Minus 3 dB equivalent to 0.707. I given you the example. If you apply to the inputs of the low pass, 10 volt, okay? And the question is right at this point here. What the voltage at the output? That means any frequency here. What is the output? If the input apply 10 volt, like, you get a F equal 100 hertz or 500 hertz. That means around here. So what is the output voltage? Who can tell me? You must be, let me know. If the input to the low pass filter is 10 volt, my question is, at a certain point right here,
10 volt.
10 volt, correct. Now, what's the name of this part right here? Remember,
Mid-range.
Mid-range.
exactly. That's what we call mid-range. Okay? And we already telling you for half passive filter, they don't have any gain. Gain equal 1. Okay? So at a certain mid-range right here, input 10 volt, output 10 volt. However, at the cutoff frequency here, what's the output supposed to be?
$7.07.
Exactly. That means they said they down minus 3 dB. Down minus 3 dB, it cannot using for any calculation. If you're doing a calculation, you have to using 0.707. So 0.707 times 10. So at the cutoff here, the output will be 7.07 volt. They down 70.7%. Okay. So you get any question on this part right here? I said any confusion, any not quite understand, then you have to bring it up. I try to find a way to help you to understand. Okay, now this is the high pass filter output. Okay, if you understand the low pass, and that's very simple, high pass. High pass means they pass high frequency signal, and any low frequency will be cut off. In the high pass filter, signal higher than the cutoff frequency path, okay, essentially unmodified, and the signal lower than the cutoff frequency will be attenuated or reduced. Okay, so basically they will be the same thing. Now, on this one here, a low pass filter has a cutoff frequency 10 kilohertz, a band of the frequency ranging from 20K to 100K is A, path essentially, B, greatly attenuated. Attenuated means reduced. A or B?
B. B.
B, correct. The thing is, this cutoff frequency 10 kilohertz. Any frequency less than 10 kilohertz will be path. And any frequency higher than 10 kilohertz will be attenuated. Okay. Now, this is the answer. Okay. Let's see that one. The cutoff frequency is the point where the output drops to 70.7% or 3 dB down from the input voltage. We already know. Frequency response, that means output. Data may be expressed in terms of output voltage, but it usually expressed in decibel. Now, if you're looking at here, okay, and you see this is just a low pass filter. On that one, they using dB. So what's the name on that part right here?
Mid-range.
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 Mid-range, that means input, output, the same.
All the same. Yeah.
That's only telling you the gain. That means equal ratio between V out, V in equal to 1. And if you're using the formula to calculate the decibel, 20 log of 1, that's why you get 0 dB. Okay.
And Mr.
Now.
Van,
Yeah. That's Mr. Smith.
I have a quick question.
Yeah, go ahead.
Yes, 0 all the way. Yeah, I'm. Can you hear me?
Yeah.
Okay, 0 all the way up to FC. FC is cut off, but that little area past FC, that's part of the low pass filter as well, correct?
What do you mean 0 dB at the cutoff? What? No related. Okay, now I telling you, they given you two pictures, two output. One they using only dB, the other using numerical value. So what I try to telling you, this part here or this part here identical. That means V out, V in the same, right? You get 10 volt in, you get 10 volt out. That will telling you the gain equal to 1. Now, you get a 0 dB. The reason you get a 0 dB, the thing is, okay, they take the 20 log of 1, again equal to 1. That's how you get 0. Okay? So now, that will be telling you one thing. What 0 dB means to you.
Input is out, same as output. Input voltage, same as output voltage.
The gain is 1.
Yeah, 0. That's a mean.
Can I answer the phone call?
That's a 1 minute. Hello. Oh, okay.
I'm just calling to let you know. So if I get back on, I'm back on. If I don't, I'll just have to wait till it come up and then review the tape.
Okay.
All right, thank you.
You know what? Mr. Smith called me.
Yeah.
He out. The thing the internet not working. That's it. Okay. No big deal. Okay, now again. 0 dB. You understand that the gain equal to 1. I agree. However, whenever they talking about 0 dB, that means you get no loss. Okay. For example, at the cutoff, you get loss. Let's get loss 3 dB. On this side, you will be going down. Okay, to 70.7%. If you get a 10 volt in, you get at the cutoff, you take 10 times 0.707, you get 7.07. You get loss around 3 volt. Okay, frequency response data may be expressed in terms output voltage, but normally they express in the decibel. So try to really understand when we're talking about the decibel. And the very important to you is when we're talking about 0 dB, only thing they mean no loss. Whatever coming in will be coming out. Decibel are units that express or measure the gain or lot the same attenuation in a circuit. The decibel can be based on ratio of the output voltage to the input voltage. And we already learned now this formula. 20 log of V out divided V in. Okay. In the type of filter study in this volume, the output voltage always less than input voltage or equal, cannot get higher. The thing is, they don't have a gain equal 1 all the time. Okay, and the rate of attenuation a lot by one the cutoff frequency a high predictable. This attenuation is 6 dB per octave or 20 dB per decade. Okay, and attenuation rate 6 dB per octave is the same as the 20 dB per decade. Okay, that means when you increase the frequency cutoff 10 times, output will be going down. Okay, 20 dB. Okay, and you know 20 dB. If the frequency is 1 kilohertz and the input coming in 10 volt.
Mr. Pham, I have a question.
Yeah.
What is octave and what is decade? The attenuation is 6 dB per octave. So how much is octave?
By 8.
Decade is 10, but octave means how much?
This one by 8, not by 10.
Can you repeat one more time? I didn't follow what?
That's by 8. Often, that means number 8.
Oh, number 8. Thank you so much.
Decade means number 10. Okay? So, you understand for low pass. From 0 up to cut off, that's what they call a pass band. Any frequency higher than cut off here will be called stop band. Okay? So the question is, what is the bandwidth of the low pass filter? The answer will be the bandwidth of the low pass filter from 0 up to cutoff frequency. Okay? Now, you have to do it for me and telling me what the cutoff frequency. For this circuitry here, they want to calculate the cutoff frequency. You get R 3.3K, C 0.005 microfarad, and this is the formula. Who can do faster? Let me know the answer. You have to do your calculation. I'm not trying to keep going. This is the one in the quiz or in the test. You must be do it. If you get the answer, let me know.
$9,650.
What do you say? What number?
9650.
9, 6, 5, 965 hertz. And everyone else get the same.
think is 9650.
That's what
Someone else, get 9650.
I got 9.645.
Kilohertz. The answer has to be in hertz. Okay, maybe they don't have an answer. So I don't care. You have to take care of that, not me. Okay. Now, I need to get a little time to talking about the left wall. Okay. The thing I want to check to see how much you understand in order to working on the left wall. Okay. So I need to stop this iPad here. Okay. I will be using my desktop. The thing is, I will be asking you the question. Okay, we go this one here. Go to the left. Okay, now, when you start running your lab, they telling you locate the low pass filter, circuit block, and connect the circuit SO. Then they want to insert the V generator for 15 volt, 100 hertz, sideways. Okay. Now, then they can tell you here, I don't care for now, but I care a calculation. Don't care for that one for now. They try to explain something. Okay, now they want to determine cutoff frequency. Okay, at the output. Then after they show, you have to enter the answer here. What happened is, if you get the right answer, they let you go to the next. Okay. However, if they say incorrect, that means you're stuck in here. You cannot move on until you get it correct. Okay. That is the thing I want to bring it up for you guys to understand that. You cannot guess. If you're doing the right thing, then you get able to get the right answer. If you not get the right answer, then you will be stopped right here, cannot move to the next. Okay, going back here. When they asking you, okay, A or B or C or D, you enter A, not work, you enter B, they working. Okay, That means they allow you to go. But when you measure, okay, then you're not doing the right thing. You will be stuck. Now, I will be asking you few things here. Okay, you see this is the board. And you're working on the low pass filter, this is circuit here. Okay. Now, you can see, let's see what I can do. Okay, let I move to the other side. Can you see?
Only your desktop, Windows 10.
Okay. Okay, that means I have to reset it. Now you see.
Yes, your lab volt and the board.
Okay, now. This is the board they want you to build. Okay, and this is the display in the left wall. So what can we make the connection here? This is circuitry original, not built like the one we want.
Jumper at C1.
Okay, so basically you can see they go
And jumper at R1.
R1. That means you need the two pole or the jumper connect here, right? Okay. Okay, then what else?
Capacitor.
That
Second.
only one you need to make a connection, right?
Yes. Then capacitor C1.
Okay. C1 here, they already connected, right? Let's see.
It looks like you have
One right here.
Yeah.
Another two pole. Okay. So in order to do it, you have to get the jumper connect right here. Okay. And
You-
also the jumper connect to this guy.
you want to bypass that inductor, right, and jump from R1 and bypass that one.
Oh, okay. You want that to bypass the capacitor.
Bypass the inductor.
Oh, okay, sorry. Bypass inductor. So that means you need to connect from here to here, right?
Yes.
Okay, that one jumper from this point to this point. Then they go over here, this point to this point, to jumper. Okay?
But
Hey.
wouldn't that place L1 into the circuit? Shouldn't we just jump from R1 all the way over and skip the middle part, skip that middle connection and plug it into the third one? Isn't L1's not in the circuit?
If you do that, you bypass everything, R1 and L1.
Well, that's the whole thing. Is a circuit
You,
doesn't
you,
have L1 in it.
sorry, you not connect this one, okay? You connect this one.
Yeah, that's correct. What I was thinking.
So R1 here, go up to here, go here, go this way, go down.
That's correct.
But
Yeah.
isn't that including L1?
Yeah, you see that? Generator coming out. Go to R1. Then go up here. Go to the right. And going down here. Go into the capacitor. That's what they want. Okay. So I say any confusion. Just
But wouldn't the current also split to go into the inductor?
no,
Even if you do,
they not go inductor. The thing is when you connect this point right here, you short the inductor. So they go this way. They not go this way.
okay.
Okay.
The general rule is the current always pass through the low resistance. An inductor have more resistance compared to a simple wire.
Yeah, they
So
short.
the current will pass through the wire.
Okay. So they will go this one here. So that's why normally when you're working, you measure you get a wrong value and you need help. When I come, first thing, I'm looking into the circuitry. That means I'm looking for circuitry want you to build. And I'm looking into the circuit you build. If I saw some wrong, then I can ask you, can you tell me, is that the circuitry you think you connect right or wrong? Okay, if you don't know, then I can tell you, you have to connect this one here, okay? Go to R1, go up here, okay? And go here. Okay, so that we done. Guarantee circuitry correct, okay. Now, next thing, okay? We'll be talking about just a 1 minute, okay? I believe you get along with this equipment. That's your oscilloscope. And this is your generator, right? Oscilloscope in here, you understand they get how many window display? How many?
The oscilloscope or the generator?
I'm talking about oscilloscope. How many windows?
Well, if you use math function, you'll have 3 signals.
You
But you
can
only
see
have
that we're talking about the oscilloscope we're using in the lab. So basically, you can get 1, 2, 3, 4, right?
4 channels, 4 signals.
Channel. For window, only 2 channel here. Okay? For window. So each window, you're able to set to be channel 1 and channel 1 and channel 2 and channel 2, right? To me, if you know how to working with the oscilloscope, I'm using only 1 channel. I don't need channel 2. If you want to measure, you can connect to where you want to measure, but you don't have to using channel 2. Except when they want to compare between the input output, then you need 2 channels. Okay? To me, just 1 channel, that's good enough. So I can set the first window, channel 1, channel 1, channel 1, channel 1. That's okay. No big deal. How can I set the first window to channel 1? You just tell me. So I know you know how to do it.
Can you repeat the question?
I want set this window to using channel 1.
You press the
How?
button next to that's
The channel 1 button or the knob? The top one I can see on the right hand side.
small rectangular.
You press this one, right?
no, you press the one that's parallel to the channel 1.
You press this one, right?
Correct.
Okay, then what? What else?
Selecting the channel and pressing the button.
When you press
The knob
this one,
position.
they will be displayed either source or the type. Which one you want?
Source.
Source.
Okay, then you have to move this one to the source. Okay, then you press this one to channel 1 or channel 2. This one, whatever channel you want. Okay, then if I say I want to using channel 1, first one to measure the peak to peak, what can I do?
Press type, select type.
Okay,
The cursor.
so you press the top here, right? Change it to the type. Then now you can press H1, whatever you want to measure. The peak to peak, frequency, VIMF, or whatever. That's a minimum when you start doing the lab. That has to be no problem. Same thing at work. You cannot asking them how to working with the oscilloscope. You are a technician. You're supposed to know. You can ask something else. Okay? So this is for the oscilloscope. Now, the other thing, when you start using the oscilloscope, first thing you want to understand, you want to AC or DC coupling. How? How do we do it? Right now, I'm talking about channel 1 only, okay? I'm not talking about channel 2.
Can you zoom little bit so we can read the knobs properly? What is written?
No, right now, you on the left. I asking you, set the channel 1 to AC coupling.
Press the channel 1 menu button.
Right, exactly. Press channel 1 button and you select it on the top here, AC coupling. Okay? The difference between AC coupling and the DC coupling. For the AC coupling, they display only AC signal. For the DC coupling, they display both DC and AC. That's a difference. Okay? And now, next thing I will be asking you, your scope probe, normally, you must be just to say, you set to be by 1 or by 10. Okay? You know how to do it, right? On the scope probe. Now, if you press it, you set your scope probe here by 1, then your oscilloscope, you must set that the same. Otherwise, you get a wrong value. Okay? So my question is, I want to set the channel 1 here by 1. How?
The volts division knob.
You press the channel,
Channel
Right.
menu.
right? You have to press select the channel 1. And up here, they will be telling you by 1 or by 10 or by 100, depending on what you set for this guy. The reason that I cannot do it, I need to buy a camera. Then I can teach you guys. Okay? But that is the minimum thing you must know without anything else. The thing is when you're asking me, first thing I have to go through is that you know how to using your scope or not. Okay. Now, when you want to press auto set here, auto set measure, press auto set that measure. When you press it,
Auto set.
auto set and measure. Normally, I think lab instructor already telling you, press auto set measure. That means press auto set, then you press measure. When you want to do it,
Signal unstable.
when?
After you got everything connected, and that's when you press it.
That's okay. However, they already connect everything. Then sometimes you still have to press auto set measure. My question is when?
When the wave signal is out of view, out of measuring view, you press auto set and measure so that the full cycle of the wave is in view.
I agree. When you set auto set measure, that means scope has a trigger. They display the way, you can see. That means when you see the signal too big or too small or whatever, then you press the auto set measure. But the thing is, what I want to tell you, whenever you change the signal, like you get 1K, 1 kilohertz, and then you change it to 10 kilohertz, then you must be press auto set measure for the scope to update with the new information. Okay? Or when you're changing something in your circuitry, after you make a change, you have to press auto set and measure. Okay, and the question, anything. If you're not, I asking you again, one more. When you say the signal is not good, look like this one, but they keep running. They keep running. They not stop for you to measure, to do anything. What can you do?
Trigger.
You can see in here, they get the trigger right here, level trigger. You can turn it to the left or to the right. That will be stop the running of the signal. The thing is on of the oscilloscope doing same thing. Okay, only the scope in the program got more money. So that's why they given you frequency, they given you period, they given you VIMF. Okay, that means too many benefits. But analog scope, they not. You want the frequency, you cannot get frequency. You must measure the period. And you're using formula, F equals 1 over T. Okay? But they work in the same way, the same thing. And now I still get let's see. Now I'm talking about, let's see, generator. Okay, now this is the generator. Come on. Man, I just got the generator. Okay, that's the generator here. Normally you can hit this generator, not like generator we're using in this program. They working the same thing. Only thing different is they not display any frequency for you. Okay? They not display any voltage, pitch to pitch or whatever. You see that? So if you follow okay, you connect the output, this output generator right here, into the circuitry. Okay, and what they say, they want 15 volt pitch to pitch 100 hertz. How can we do? The thing on this generator, you don't know what frequency.
You connect this and adjust the dial, but you read it off the oscilloscope.
Okay, so that's what you mean. You connect output of generator here to the scope channel 1, right?
Yes.
Okay, I agree. Then what next?
Then you want, was it 100 megahertz, 100 hertz?
Yeah,
So for the range, you push times 10.
the range will be 1K. That's okay.
Times 10.
Okay,
So the second button.
yeah.
Yeah.
That means you can 1K, you still get up to here. Okay, that's just a range. So
Then-
pretty accurately, you put 200, that'd be fine. Okay,
Then
then
you turn the dial to 1.5.
right here, right?
Yeah, 1.5.
Okay, that means right now you display the signal sideways in the oscilloscope. Okay, and then only thing is on the channel 1 of oscilloscope, you set it to be frequency. Then you can change this here until your oscilloscope says 100 hertz. That will be 100 hertz. You don't care what the number here. Only thing oscilloscope display 100 hertz. Then you can change the amplitude here to get the 15 volt. That will be correct. That's how you get a sideways 15 volt, pitch to pitch 100 hertz. Display on oscilloscope. You don't care what else here. Only thing scope telling you 100K, 100 hertz, 15 volt. You'll be fine. Okay. Then now you connect generator to the circuitry here. And also oscilloscope in this position. And suppose they display exactly the same. Okay. That means 15 volt and 100 hertz. Then you will be measure the output here. So If you're looking into instruction of this program, they connect channel 2 here, okay, to display the output. But I said to me, I can take this, I connect to the output to see what display on the oscilloscope, okay? But if you're using channel 2 to connect here, okay, either you can see the signal or you cannot see the signal. Now I'm talking about first one. If you not see the signal display on channel 2, what can you do?
Press auto set measure, assuming all the wires are correct, of course.
Okay. You see my question. They telling you connect channel 2 here, and you measure the display on the oscilloscope. You can press auto set measure, right?
Yes.
And you get nothing. Or you get wrong value. How can you do?
Check your source setting.
What? You already know the source right here. Already display on
From the-
oscilloscope.
From the oscilloscope setup, you have to make sure you have your source set up for channel 2 if you're using channel 2.
How can you do? You're just telling, suppose, like I tell the student, have to do what? Not just general. I cannot say, you take your scope channel 2.
Just disconnect where your probe is and then connect it at the generator to see if your cable's working. And if it's working,
Okay, now I agree. So in this case, we don't know the circuit get a problem, or your scope channel 2 get a problem. So we have to isolate one by one. First thing, I want to guarantee channel 2 working okay. In order to do it, I can connect channel 2 into here. They working right. That means they will be displayed exactly channel 1. If they working exactly channel 1, that's telling me scope channel 2 have a no problem. Or if they not display, same thing is channel 1, telling you something wrong with the channel 2. Maybe connection, maybe oscilloscope probe, maybe set by 1 or by 10, or maybe not AC or DC coupling. Okay? So now, if you check that one by connect channel 2 to in right here, you get exactly the same signal like channel 1. So you don't have any problem with scope channel 2. Now you connect back into here, and they still not get the right answer. What can you do?
Call the instructor because there's something wrong with this circuit.
Okay, now I can tell you. In this case, you positively know what you're doing, correct? Then you need the lab instructor, okay? And what they want to do, they will be remove this board, get another one, okay? Plug it in and try again. If you get the right value, something here must be wrong. So they have to make a note for that circuit board so we can fix it. You can see that the whole process. You get the lab done. Like, when you're working in the lab, you get a problem. Then you can ask me, I on the Zoom. Then I can help you, telling you what to do in order to fix the problem. And you understand me, when you get into the lab, the ball already sit there. You cannot remove, okay? Only thing is you make a connection for your circuitry and also connect generator, connect scope or meter, whatever you need. If you get a problem, then you asking lab instructor or my assistant, Mr. Sam. They will be helping you. Okay? Don't do anything if you don't know exactly what you want to do. Electronics is not lucky. Okay? So when I get the camera, I will be set up to helping you. Guarantee when you do the lab, you know what to do. You get a problem. I try to do a problem solving. Okay? That means you do it and they not come out like we want. We get a problem. How can we fix it? Any question up to this point? The thing is, I don't want to run to telling you, okay, we connected one, we get how to measure it. You already know to do one time. Next time will be not a big deal. Instruction tell you what to do. Okay, any question? Anything? No? So basically, now you know how to do what to do. But the next time, I hope when I asking you, you can answer me. That means when we get a problem, telling me how do we do to correct it. Okay, any more problem? Anything else? No. Okay, Mr. Sam.
Okay, thank you, Mr. Pham. Okay, so just make sure you go to the website, go to the handout, and make sure you just download the AC Quiz 07 Summer 2021 report, and that's where you're going to put all the answer for this quiz. Okay, so I'm going to minimize this one out the way. I'm going to run the test. Okay, so here we go. Okay, can you all see that?
Yes.
Yes.
Okay, okay, very good. So on question number 4 on your answer sheet, they said watt as a unit. Make sure you answer the answer is in milliwatt, okay? Okay, so that's pretty much it. So anybody, so make sure you upload it to the website, and it must be done. Must be uploaded before 12 noon tomorrow. Okay, so make sure.
Excuse me, what's the name of the thing we have to the place where we put our answers on? What was it called again? You know, where we have to put our answers and then
1 second, 1 second.
Sorry about that.
Right here. Go to your handout.
Hold on. Can you put your cursor on the one we have to
Website.
uh-huh. I mean, which one?
Handout.
Yes, handout. Is it
First
a
one.
Okay, I got it. I got it.
Okay. Okay, so that's it. So make sure you put those answers in there and upload it onto the website, please. Okay, before 12 noon. Thank you. Okay.
Thank you.
So no one get a question about the quiz. Okay, so good night, everyone.
Good night.
Good night. Good night.